Everyone, today we'll be dealing with the next topic other than this hydrogeology. Yesterday we studied about hydrogeology. Okay, so now we'll be studying about the subdisciplines of hydrogeology. Okay, so when we talk about this subdiscipline of hydrogeology, apart from being a geological engineer, apart from uh, dealing with all the groundwater resources and all, we have to deal with certain things which are related to it. Okay, so all these subdisciplines, or you can say all these, these are what the branches of the hydrogeology itself. Okay, so in that regard, the very first module is your water resource evaluation. So once you deal with all the study of underground sources like aquifers and aquiclude, aquitard, all these things you have studied. So you know how to extract water. You know where to extract water. Okay. So all these things are relevant to what? To a specific field which is known as water resource evaluation. Okay, so this water resource evaluation, this entire module deals with what? It deals with how much water. It deals with all these findings, basically all the findings which you will be performing there. What are these findings? These findings are this thing: how much groundwater is stored over there, and how much amount of that water could be extracted. Then what are the sources of that water? That means in order to put that water into some sort of use, you need to first identify and investigate that what are the sources of the water, and what could be the possible characteristic. Okay, see, for example, water containing too much of hardness, it is not fit for domestic use as well as the industrial use as well. Okay, so you have to give a preliminary idea. So this is what water resource evaluation deals with. Okay, then all the aspects related to the quality of the natural water which is occurring, that will be covered under this water resource evaluation. Basically, as the name suggests, the evaluation of what? The resource of water. Okay, whatever the resource is there, evaluation of that. Okay, so that is your water resource evaluation module. Then comes your contaminant hydrogeology. Contaminant hydrogeology basically deals with what? With the degradation of water quality due to human influences. That is, in short, contamination only. Okay, so literally the contamination of water that is taking place due to what? Due to all the man-made activities. Natural causes, we keep those aside. Okay, while we study this hydrogeology, there are natural causes as well, but there are remedial measures by nature itself, like self purification of lakes and water stream. Those are all taking care of the natural contamination. But what could be natural contaminant? Natural contaminants are what? Nothing but just impurity, either organic or inorganic impurity. If they are inorganic, then there is no need to purify, or no need to remove them. They doesn't cause contamination, they only cause turbidity, which is removed. Okay, and if there is contamination due to the organic resources or organic impurities, then the self purification, there are natural process. Okay, all the dissolved oxygen, BODs, all these in microorganisms, they take care of the organic matter. But when it comes to the contamination due to human influences, that is something which has to be taken care by ourselves. Okay, so in order to remove all these contaminants, and in order to take care of the resources from these contaminants, we need to first study what are the sources of the contamination and how they are impacting the groundwater. Once we have an idea of these two things, then we can easily go for the removal of the contaminants, or you can say the prevention of the contamination of water. Okay, so in this particular diagram, okay, you can see this is a very clear outline of how the this thing, contamination takes place due to industrial causes. Okay, this shows the depiction of industrial causes. Then groundwater and the water cycle are quite interrelated. See, in previous lecture also we have studied that the water cycle plays a very vital role in geological the same consideration. Okay, so the groundwater and water cycle both are interrelated. How they are interrelated? Because this is the part that you have left in the earlier studies also while studying water cycle. Okay, so how they are related? What are the main thing? That is permeability and infiltration. These two things are very important factors which relates the groundwater to the water cycle. How? See, whatever the form of precipitation will be coming on the ground, it will be infiltrating into the ground surface, and then only the water table, or you can say the groundwater resources, may be recharged. Okay, so this recharging takes place. How does it take place? By when the water moves into the thing, soil surface and earth surface, and it percolates into the till the water table. Okay, so what happens over here is whatever amount of precipitation or form of precipitation comes on the ground surface, it will be moving directly where? Directly into the resources, groundwater resources. Okay, so there are certain things like infiltration capacity. What is this infiltration capacity? The ability of the ground, okay, to let the water easily pass into the surface. Okay, so the ability of the water, the ease with which the water can percolate into the ground surface, that is your infiltration capacity. This is non-technical. Technical terms, there are more, technical definition of infiltration in geotech and soil mechanics and all. Okay, but as of now, just understand what is infiltration capacity. It is the ease with which the water can percolate into the ground surface. Okay, so this causes what? This causes the groundwater recharge. Then another, factor, or you can say influencing factor over there, is the groundwater flow. Okay, see, apart from percolation, okay, what if the water percolates into the ground surface and it doesn't flows to the water table, up to the water table? Okay, then only what will happen? Perched aquifer will be formed. Water will move somewhere, it will be entrapped somewhere, and pockets will be formed, and therefore perched aquifers will be formed. Okay, so equally important, infiltration के साथ साथ equally important क्या है? Equally important है ground water flow को होना. Okay, so the groundwater flow should take place continuously. Okay, that is the reason why the that is the reason how the precipitation will fall on the ground, then it will infiltrate into the ground, and due to this groundwater flow, it will be able to reach up to the groundwater resources, that is your saturation zone. Okay, yesterday we have studied two different zone, vadose zone and saturated zone. Okay, then there is your another subdiscipline, that is your bedrock hydrogeology. This bedrock hydrogeology is something which we have studied in structural geology also. Okay, over there also when we were studying structural geology, तब हमने देखा था कि there are certain rocks or certain geological structures there are certain geological structures where what is there, joints are there, or at certain time fractures are there, but movement is not there in the rocks. Okay, so what happens at that those places? What happens is those places, the water will find its way to be entrapped in that. Okay, and that is something, the movement, or you can say, you know the allowance of the movement of water in the rocks, that is known as your hydraulic conductivity of bedrock. Okay, so this hydraulic conductivity, see, in the similar way, normal electrical conductivity, how do you define electrical conductivity? The ability of any material or medium to what? To transfer electricity or to carry the electric current, that is your electrical conductivity. Okay, so in the similar way, when it comes to water, okay, when the this bedrock, okay, whenever the bedrock is able to transfer the amount of water from one instance to another instance, that transfer is not taking place under certain forced flow. Okay, it is taking place naturally. Okay, so that is your hydraulic conductivity. This hydraulic conductivity of bedrock, it is actually controlled with the help of what? With the help of size of fractures opening. It depends upon size of the fracture opening. जितना ज़्यादा wide तुम्हारा fracture होगा rock में, उतना ही ज़्यादा क्या होगा? Conductivity high होगी. Then spacing of the fracture, again the same thing जो हमने पढ़ा था, joints. What are joints? Joints are nothing but fractures with no movement. Okay, if there is certain some sort of movement in the joints, then what will happen? Spacing ज़्यादा create होगी, and again the conductivity will be increased. Similarly, interconnectedness of fractures. पानी बेसिकली बेड रॉक में पानी मूव कहाँ करेगा? इन द फ्रैक्चर्स ओनली, ठीक. So if one fracture is somehow connected to the other fracture, let it be any hairline crack or any, you know, passage, internal passage, or you can say some external grooves are there in the rock, bedrock. Okay, anyhow, if two fractures are connected, yeah, to each other, then that interconnectedness of fractures will do what? They will increase the hydraulic conductivity of the bedrock. Then another subdiscipline is your groundwater recharge. Okay, so this groundwater recharge is what? How does it take place? As we have discussed, whatever precipitation, whatever form of precipitation is there, it will be ultimately coming on the ground surface itself, and from there, due to permeability, due to groundwater flow, due to porosity, all these things, all these properties will allow what? They will allow the form of any form of precipitation to what? To percolate or to infiltrate into the ground surface. Okay, apart from this, what happens apart from this, there is one more thing. Whatever this thing, open water bodies are there, they'll be directly receiving the what? They'll be directly receiving the precipitation, and therefore even they will be contributing to the groundwater recharge. See, for example, in this particular diagram, you can very easily see there is this river in the open atmosphere. Okay, what this river will be doing? This river will be receiving the entire precipitation in its own, and ultimately at the bottom of the river, what will be taking place? In the river bed, infiltration will be taking place at certain level. Okay, even if along with the, you know, river bed, at the river banks also, near the river banks also, what will happen? This water will percolate or infiltrate into the ground surface. Okay, so this groundwater recharge depends upon the velocity. Velocity of what? Velocity of the flow of the this thing, either runoff water or groundwater flow. Okay, so this velocity is proportional to the what? The velocity of recharge. Okay, the velocity of groundwater recharge, this is proportional to permeability and the slope of the water table. If the slope of water table is high, then the velocity of recharge will be high. If permeability is high, then greater permeability. अगर रॉक सरफेस तुम्हारा ज़्यादा परमिएबल है तो क्या होगा? वेलोसिटी ऑफ रिचार्ज ज़्यादा होगी, दैट इज रिचार्ज जल्दी होगा ग्राउंड वाटर का. Okay, and similarly it is inversely proportional to the porosity. Now see, permeability and porosity are two different things. That is the reason why this velocity of recharge is directly proportional to permeability and inversely proportional to porosity. Okay, permeability means the ease with which the water is percolating into the ground surface. वो जितना ज़्यादा होगा उतनी वेलोसिटी ज़्यादा होगी, यानी उतना ही रिचार्ज जल्दी होगा. लेकिन पोरोसिटी, ओके, if porosity of the bedrock or you can say the earth's crust is more, तो रिचार्ज क्या होगा? जल्दी होगा या कम होगा? तो रिचार्ज वेलोसिटी कम होगी तुम्हारी. क्यों कम होगी? पोरस है तो जल्दी होना चाहिए. If the porosity is, you know, more, then why recharge of groundwater surface is less? Is anybody who can answer this question? There's a very small difference between permeability and porosity. No one. See, I'll tell you. If porosity is more, what will happen? The water, instead of, see, you all have studied this, you know, physical chemistry. See, physical chemistry, mein you all have studied the packing density, the spacing between molecules and all. Okay, the bond between molecules. See, so uh, in that aspect only, just consider the Earth's surface as molecules. Okay, the soil particles as molecules. So what will happen if the space between the molecules, or you can say the soil surface, is more? That is porosity. What is porosity? Volume of voids upon volume of the solids. So void ratio, that is your this thing, not void ratio. The volume of void is more. Then what will happen? Instead of, you know, the water will percolate into the ground surface, but instead of reaching up to the, you know, saturation zone, what will happen? it won't be binded to the soil particles. Permeability, see, the water, in order to get the water infiltrated up to the saturation zone, what should be there? A certain binding property should be imparted to it. ठीक, ऐसे नहीं है कि पानी कंटिन्यूसली बह के गया। ठीक, अगर पोरोसिटी ज़्यादा होगी तो क्या होगा? द फ्लो विल स्टार्ट टू हैपन। Okay, the rapid flow will start to happen, and that rapid flow, it will do what? It will go in the direction where the slope is there. Wherever the slope is there, it will move in that direction. It won't be moving in the downward direction. It will be moving at a negative gradient, but it won't be moving vertically downwards. So that is the difference why the groundwater, this thing, the velocity, groundwater recharge velocity is inversely proportional to porosity. Okay. So again, the same thing, the natural water table fluctuation. See, with this, just we talked about this infiltration. Okay, due to infiltration, what happens? The groundwater recharges. If the infiltration is reduced, then what happens? अगर infiltration कम है, पानी का infiltration कम हो रहा है, तो ग्राउंड वाटर का रिचार्ज वेलोसिटी कम हो गई, और रिचार्ज वेलोसिटी कम हो गई तो कंजम्पशन तो उतना ही हो रहा है. तो what will happen? This water table will lower down. See, in the image you can clearly see, in the first one, the saturation zone, the depth of saturation zone is too much. That is, the water table की जो phreatic line है, ठीक है, this phreatic water table line, it is quite high. लेकिन in the second diagram, you can clearly see the phreatic line has moved downwards. Okay, so why it has it is done? Why it has occurred? Because of the reduction of infiltration. Okay, see again this thing. Okay, so reduction of infiltration is something which can be caused due to various reasons. Now these causes can be either natural or they may be artificial causes also. So when we talk about natural causes, it is the seasonal variation. Okay, due to those seasonal variations, structures like wells will go dry. Okay, then spring, whatever water comes out of spring, they will be what? That water will not be coming out. Why? Because water table has already dropped. Then discharge of the rivers drops. Okay, all of you must have observed that